Okay, there are a few special cases I want to go over with impulse. They're more complicated, so I just want to go over those. So this one, if you have a change in direction, remember momentum is a vector, so it has a direction, so there's a positive and a negative. It's just like velocity. So I want to draw this picture, and I'm not an artist, but so you've got this tennis player. There we go. And there's this tennis ball cruising along towards the tennis player at 30 meters per second. So I'm going to say that the right-hand direction, let's see, this way I'm going to make plus, and the left-hand direction I'm going to make minus. That's just standard physics. Right is positive and left is negative. So that means that this ball, if it's traveling toward my tennis player, it's going at negative 30 meters per second because it's in the negative direction. And in your problem, they're not going to specify that always. You have to draw the picture and realize that the ball is going one direction in one case and the other direction in the other case. And so you could have flipped this around and had the ball coming at the tennis player from the other direction. That's fine as long as you have a picture and you know which way is positive and you know which way is negative. So then the tennis player is going to hit the ball. Okay, I'm going to just draw that down here. So the ball comes over to the tennis player and then it gets hit this way again. And it's going to be going that way at 30 meters per second. And this time it's a positive 30 meters per second because it's going in the positive direction. So that means that my initial velocity, v1, is this negative 30. And my final, the v2, is the positive 30. Okay. So now I'm going to write my formula. Okay, so the reason I had to have my positives and my negatives is because otherwise I would have, the mass is the same in both cases. So mv2 would have matched mv1 and they would have canceled each other out and there would have been no impulse. There would have been no force. There would have been no time. And that just doesn't make sense because we know there has to be a force. The tennis player hit the ball with some kind of force. And so I have to make sure I distinguish between the positives and the negatives so that I get the right answer and that I actually end up getting a force. So F is the one I don't know. That's actually what I'm solving for this time. T, they're in contact for 0.1 seconds. M is the ball, 0.1 kilograms. V1, or no, V2, I want to go in order. V2 is the positive 30 meters per second, and V1 is the negative. Okay, so now that I have all that figured out, I'm going to go plug it all in. Gotta go kind of crooked. Let's see, positive 30, and then my mass is the same. Alright. So I'm going to simplify a little bit here. So I've got this left-hand side stays the same. 0.1 times 30, that is 3. And then over here I have a minus 0.1 times negative 30. That's minus a negative 3. A minus a negative, those negatives cancel and turn into one big plus sign. So I'm going to change that. So really I've got... Oops. I've got that my impulse, this F times time, equals 6. And then let me scroll down a little. We will have to divide to solve for F. Now I get that F is 60 newtons. Okay, so if you're having a change in time, that's going to happen with sports. When, like in baseball, a ball is traveling toward you at some such speed, and when you hit it with the bat, it's going to be going in the opposite direction, so you have to change the sign. It would work the same with soccer. I don't know that you'd really do that in basketball or football, but any kind of sport where you're hitting the ball with something. So any of those racket sports or baseball, anything like that. Then the other one, I want to go over a more complicated math problem. So let me write out my formula again. I always want to write that just so I have it in front of me. So F, 25 newtons. T, it took 5 seconds. M, that's what I don't know. V2, I ended up at 6 meters per second. V1 started at 2 meters per second. Okay. So I'm going to go plug all this stuff in. Okay. 25 times 5, that's 50. No, well, not 50. Sorry, 125. And then M times 6, I'm going to just leave that the way it is. And M times 2. So now it looks like I have a problem, because before when we came across two unknown variables, there was an issue. But here, they're the same variable. So I'm really going to see that this is still 125. This is like I have 6 m's and I have 2 m's. So if I have 6 m's, take away 2 m's, I'm left with 4 of them. Okay? So 6m minus 2m. I did switch the order there, but that's okay. I can rewrite that. Okay, so 6m minus 2m gives me 4m. And then to calculate m at this point, I will divide just like we've done before. So that one. $31.25 kilograms. Okay. Then the last one I want to go over is more complicated, solving for velocity. The example I did before, it had zeros, and that makes everything easier, so I want to go through one that's a little more difficult. Okay, so write your formula. Oh dear. Write it correctly. Okay. So force, 100 newtons. Time is 5 seconds. And 10 kilograms. V2. That is what I don't know. I'm looking for the speed at the end. V1 is 4 meters per second. Okay. So go plug all that stuff in. I've got 100 times 5. Okay. So I'm going to go simplify everything I can simplify. I have 100 times 5. That's 500. I have 10 V2. I can't really do anything with that yet. And I have 10 times 4, which is minus 40 here. Okay, now to solve for V2 here, I have to get V2 by itself. So the first problem here is I have a minus 40. So I got to add 42, get rid of that. And those go away. And now it looks normal, just like everything we've done lately. So I'll divide by 10, and I get 54 meters per second. All right.